Thanks, Eddie. I'd like to start out by saying you all are amazing. I mean, really amazing. And I want to show you just exactly what I mean by that, so watch closely. Now you'll notice that no one in this room suddenly jumped up and said, "Oh God, who is this strange new man in front of us and what happened to the old speaker?" And that is because humans are amazing at distinguishing patterns, even if they're distorted or change. And this is something which even the most powerful of modern computers continue to have difficulty with. So I'd like to talk about that a little bit, talk about that difference, and understand why that distinction is so important. So a lot of us make a mistake every day. I make it, most people I know make it, maybe everyone in this room makes it. When working with a computer, we treat it kind of like a brain. It's something which is there to think for us and to perform many of the tasks that we usually associate with humans. And if we look at the history of computing, it's understandable why we make this mistake. A little bit of trouble here. Hold on just one second. There we go, much better. 1965, first computer serves as a psychologist. In 1979, computers start making medical diagnoses on their own. 1985, you like this painting? Great, a computer painted it. 1997, computers become the undisputed chess champions of the world. 2011, computers start beating us at Jeopardy. 2029, computers sent back in time to kill Sarah Connor and become governor of California. Now, given this, it's perhaps understandable why we start to treat computers as thinking beings, as brains. And yet, despite all this, there is still this fundamental difference, that something which is so easy for you, this ability to recognize distorted patterns, remains so difficult for computers. So we'd like to understand why that is, why this difference. And what it comes down to is the fundamental way that computers process information, which is different from the way brains process information. Computers consist of a bunch of transistors. And those transistors have just one job, to evaluate whether a statement is true or false. And it does that through just three operations, and or not. If I tell a computer statement A is true, statement B is false, are both statement A and statement B true? The computer would say no. If I said statement A is true, statement B is false, is either statement A or statement B true? And the computer would say yes. If I said statement A is true, is the opposite of statement A true? The computer would say no. And out of just those three things, that forms the complete basis for how computers process information. So if you were looking to pursue a computer science major, don't worry, we covered it all right here. But this is very different from the way neurons work in the brain. And that is because neurons are based not on Boolean logic, but on associativity. When we think about things, when we process information, we are simply associating different ideas together. When I think of A, I think of the letter. I think of the article, A and the. I think of apples. I think of grades. I think of my sister. Her first name's Angela, starts with an A. I think of Hester Prynne from The Scarlet Letter. And all of these associations are what allow me to do all the things I do as a human. And this is what makes certain things easy for humans, but very difficult for computers and vice versa. So if we look at the things which humans are good at, we're great at pattern recognition. We're great at innovating, taking some pattern and developing a new way to look at it. We're great at generalization. We're great at motor control. On the other hand, we're terrible at doing calculations, dealing with probability, dealing with enormous amounts of data, doing things by trial and error. And these are all the things which computers are good at. So when I was asked to give this talk, I was told that the DICE talks were kind of like TED Talks. And I know that TED Talks, the sort of tagline is ideas that change the world. And so how can we use our understanding of this distinction to change the world? Well, what I would argue is that understanding this is the key to realizing how we should be dealing with technology on an everyday basis. We shouldn't just be treating it as a brain. And so for most of what we do with computers, this is an easy thing to understand. If there's something the computer does well, we shouldn't necessarily task our brains with doing it. We should free up the time that our brains would be doing that to do stuff like this. Where this gets fun and tricky is at the edge cases. What if we have a task which requires an intense understanding of Boolean logic, but also requires tremendous innovation? For instance, when we're programming a computer. How do we deal with that? Well, the answer is that we train these computers up here to be a little bit more like those computers over there. Similarly, we sometimes would like to be able to make use of the edge case in the other way. Computers are great at dealing with a ton of data. That's how Siri works. She's able to take all of this tremendous amount of data, funnel it through her algorithm, and tell you exactly where to find that ingredient for your next recipe. But what we would like to do is take that a step further. We'd like to take all that big data and say, hey Siri, you remember that restaurant I went to and they had the kind of spicy dish which I really liked, and I was there with Sue, and goodness, you must know what I'm talking about, Siri. We would like to be able to interface with computers in exactly that way. And so that brings me to what I have been working on recently, which is building just a little bit of this sort of associative logic into computers. This isn't what they're good at, but by adding just a little bit, we can make tremendous progress in the way that we interface with computers. So I'd like to give just a very brief demonstration of that in the form of a program which is designed to do one of these tasks, which is usually given to humans. That is pattern recognition. So given that, I created a program and trained it to recognize the faces of every member of my lab. And then I fed it distorted pictures of those faces and asked it, do you recognize this person? And by going through this process of association, the computer is able to turn that initial garbled mess into something which we recognize as a human face. And so by taking advantage of exactly this sort of association, we can learn to interface with computers in a more meaningful way, which will let us spend more of our time off innovating, generalizing, not spending all of our time sitting there saying, goodness, Siri, why can't you just understand what I want? So I started this by saying that you all are amazing. And the fact that you can recognize me with my hat off, that's great, but it's not that amazing. What's really amazing is that once I took my hat off, all of you laughed. Through that great web, interconnected associations, which you store up in your head, you were able to realize that something strange, incongruous, funny was going on. And it'll be a long time before computers are able to do that. Thank you.